welcome to a short lesson on scientific notation. Scientific notation is not an unfamiliar type of notation for you. You've definitely seen this in other courses, but it is very important to keep in mind that there are some really important things that scientific notation is used for. I once took a course that had a lot of non-science majors in it, and two women became very upset and thought that scientific notation was very stupid and should never be used. So I hope to at least impress upon you that scientific notation isn't used to make things more difficult. It's used to make things easier and a little bit more readable. So scientific notation is very useful, especially for very, very large and very, very small numbers. When we talk about numbers of atoms, for example, atoms are very small, so samples of atoms have a lot of atoms in them. We're going to talk about a number called Avogadro's number that actually is a huge number, so scientific notation makes it a lot easier to write. An example of a huge number is up here, 1, 2, 3, with a whole bunch of zeros. We want to turn that into scientific notation. The decimal would end up here, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That tells us that this is 1.23 times 10 to the 11th. So that is, a lot neater looking, a lot easier to read, and much less to have to deal with. And there's actually a pretty easy way to type that into our calculator. A decimal with a lot of zeros, like this one, 1, 2, 3, 4, 5, would end up being 4.54, times 10 to the negative 5. This also helps clarify a lot with significant figures. You'll notice that this number really has 3 sig figs. But those leading zeros can be a little bit confusing. So now this is a lot more clear that we have those 3 significant figures, and those other zeros are actually just placeholders that don't count. Parts of a number in scientific notation include the mantissa. This has to be a number between 1 and 9. Sometimes you might see someone write like 10.5 or something. Not exactly correct scientific notation. For the types of things we do, it's okay, but really technically that number should be between 1 and 9. If you get to 10, you should actually move that decimal place over and change your exponent. So our exponent is how many times you're going to move that decimal place. When you have a positive exponent, it means that the number is large. So if we look back on our prior slide, our really large first number has a positive exponent in the scientific notation, whereas our second number, which is a decimal, has that negative. So that's just something important to keep in mind. If you take a number that's a decimal and you turn it into scientific notation, it should absolutely have a negative exponent. If it's a number that is greater than 1, so it's a non-decimal number, it should have a positive exponent. So we're going to take a little practice, write a few of these in scientific notation. The first thing I have to do is kind of glance at it and predict, will it be a positive or negative exponent? So my first one here is a large number that's going to have a positive exponent. So in order to put the decimal place right here, I have moved that decimal 1, 2, 3, 4, 5, 6, 7 times. I need to keep all my sig figs, so I do have to relate that to what we talked about yesterday. 3 and 4 are my sig figs here. So my final answer should still have that 3 and 4 and account for the fact that I moved the decimal place 7 times. So I didn't change anything with sig figs, and I moved my decimal 7 times. This was a large non-decimal number, so or a large number greater than 1. So I do end up having a positive exponent. In order to move my decimal place to right here, I would be moving it 1, 2, 3, 4, 5, 6 times. Again, keeping my sig figs, my 6 and my 7. So this is going to be 1.67 times 10 to the negative 6. My next one should have a positive exponent. I'm going to keep all my sig figs here. 1, 2, 3, 4 times I'm moving the decimal. So as you'll notice, I kept all of those numbers because they're all non-zero significant numbers. I moved the decimal 4 times, so 2.5846 times 10 to the 4th. You should also really be able to relate these to standard notation. This probably is a little bit less useful in most cases, but if you have, for example, 5.7 times 10 to the 8th, sometimes it's helpful to kind of just rewrite this where you have a little bit more room. and you're going to go 1, 2, 3, 4, 5, 6, 7, 8. So because this is a positive number, I want to make sure that I'm moving my decimal to the right, and I'm going to get a large number here. So I'm going to end up with 1, 2, 3, 4, 5, 6, 7 zeros. So again, this is a great example of why it can be helpful to write things in scientific notation. With my negative exponent on the next one, I'm going to be moving my decimal to the left. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Holy cow, that's 10 zeros. No wonder scientists like scientific notation so much. Punching scientific notation into your calculator can often give students a little bit of a struggle. You might want to use a caret, you might want to use some other buttons that you've used before, like you might want it to look like scientific notation, so you punch in like times 10 or something. Don't do any of that. There is actually a scientific notation key because of how important scientific notation is. It looks like two little capital E's in a lot of calculators. Using a graphing calculator, you're going to see it as the second function of your comma button. If you're using a different type of graphing calculator or scientific calculator, you're often going to still be able to find this E button. On some calculators, it may be called EXP. Again, don't be using times 10 or the caret button. This can kind of get you into some trouble. Sometimes it'll work okay, but there are times where it will not. So if I wanted to punch in 2.3 times 10 to the negative 5, I'm going to hit 2.3 like you would expect to. Only instead of punching in all of this, I'm just hitting this E button. It'll only come as one E, even if there are two on the button. You'll just see one little E there. Then you're going to use the negative sign. So again, not a minus, but there's an actual negative sign that just is negating your answer, but not actually doing any subtraction with it. So you can find that on whatever calculator that you're using. And then the number 5. And this will actually put this into your scientific calculator in scientific notation for you. You'll also notice that if you do math and your answer comes out in scientific notation, on a graphing calculator you will see that little capital E telling you the exponent. Some scientific calculators actually do have the little exponent function on them, so it may read out a little bit differently. Just something to try to make sure that you are mathing correctly. You're going to divide 2.5 times 10 to the negative 5. So what you're actually punching in is 2.5 weird E negative sign 5 divided by 6.2 weird E 3. Depending on your calculator, it may be helpful to keep each of these in parentheses. It's never a bad idea. You punch this in, we should have 2 sig figs in our answer, so you should get something that rounds to 4.0 times 10 to the negative 9. Just to kind of give you a little heads up on reading your calculator, what you'll actually see on your screen is probably more like this. Again, we just want to take our 2 sig figs, and this right here actually translates to times 10 to the negative 9. So what you would actually write down as your answer is 4.0 times 10 to the negative 9. To prove this to you mathematically, if we divide our two mantisas, we would get 0.4. Okay. If we take our two exponents, which are negative 5 for the first one, and positive 3, but we're dividing them, so we're going to subtract negative 5 minus 3, we should have an exponent of negative 8. So what that would really give us in scientific notation would be this, which is not correct scientific notation. We got to move our decimal over 1, which ends up with 4.0 times 10 to the negative 9.